Welcome back, Wildcats. Today we're going to take some notes on point slope form. We're still working with linear functions and linear equations. This is just going to be a different form that we might find a linear equation. And this is what we're talking about here, point slope form. Now, just to review, the form that we talked about last time is here, slope intercept form. Okay, and a reminder, what slope intercept form is. This is it, y equals mx plus b. This is the general form, and anytime we have a specific equation in slope intercept form, we plug in a number for m and we plug in a number for b. And a reminder as to what these stand for: m is the slope and b is the y-intercept. And that's why it's called slope intercept form, because we use the slope and we use the y-intercept. Okay, so here's an example. Write the equation of a line with slope 3 and a y-intercept of -6 in slope intercept form. Okay, so slope intercept form, I'm going to write the general equation right here. Y equals mx plus b. And now I'm going to plug in. Let's see, let me write this down here. Slope of 3, let me write it like this. This means m equals 3. And a y-intercept of -6, that means b equals -6. So this is what we're going to do on our next step. Take a 3, plug it in here. Take a -6, plug it in here. Okay, that's what it says here. Substitute m and b, so we'll get this. Y equals, replace m with the 3, replace b with the -6. And notice here we have plus a negative number. Maybe we write it like that just to kind of separate those two signs, the plus and the negative. But ultimately, when you're adding a negative, it's the same thing as subtracting. So we're just going to write this 3x minus 6. Okay, anytime your b value is a negative number, just write it as minus that number. There it is. Okay, that's slope intercept form. This is what we talked about in our first set of notes. Now we're going to talk about a different form, still of a linear equation. It's good to know these different forms. Depending on the situation, one can be more helpful than another. So point slope form looks like this. This is the general form. Y minus y1 equals m parentheses x minus x1. Okay, where m is the slope, that hasn't changed. Here, x1, y1 is a point. So here we're writing an equation using a point and a slope, and that's why the name is point slope. Now, the point that we use can be any point on the line. So as long as we know any point on the line, we will be able to write an equation in point slope form. And when we do that, when we write a specific equation, we take the general equation and we're going to have to plug in three places. We're going to have to plug in the slope for m, and our point, right? So we plug in m for slope. Our point is two coordinates, an x1 and a y1. So these are going to get plugged in here and here. So we'll basically plug in three numbers into those three spots. Okay. So it says here, write the equation of the line with the slope of 2 that goes through the point 4, -3 in point slope form. So here, this is what we're given. Slope of 2, so our m is a 2. And over here, we're given a point. Notice we don't know the y-intercept because they didn't tell us, but we do know this point, 4, -3. Remember, the first number is always an x value. The second one is always a y value. This is our first point, our only point. This is our x1 and our y1. So we've got the three numbers that we're going to plug in. Let's go ahead and do it. Let me write the general form of point slope, which is y minus y1 equals m parentheses x minus x1. And now this is what we're going to do. Plug in a 2 for m, plug in a 4 for x1, plug in a -3 for y1. Let me go ahead and do that. Y minus y1 is a -3. Okay, now look here, be careful. Notice that there's a negative sign in the formula, so we're always going to have that negative. And in this instance, our y value, our y1 value, is also a negative number. So here we're going to get two negatives back to back. So y minus -3, I think I'll write it in parentheses like that. Replace the m with the 2, x minus x1, our x1 is a 4. There it is. And let's simplify this. The one thing we can do here, when we have a negative back to back like that, when you subtract a negative, same thing as adding a positive. So this is going to turn into y plus 3 equals 2x minus 4. And there it is. There's the equation of the line in point slope form. Okay, look, what I would like you to do, pause the video and try these two examples. You're going to do the exact same thing. Here they give you a point and a slope. And if you want some help labeling this, x1, y1. So go ahead, pause the video, and then plug these in, see if you can write these equations. Then you can come back and check. Okay, let's take a look at the next page. Here it says, if you're given 2 points, but not the slope. Step 1, calculate the slope using the slope formula. Step 2, substitute the slope and one of the points into point slope form. Okay, let's see what this looks like. Example 3, write the equation of the line that passes through the points -1, 4 and 5, 8. All right, so notice here, they don't tell us what the slope is. They just give us 2 points. But remember, we do have a slope formula. If we know 2 points, we can calculate the slope. That's what we're going to do here. Let me write this down as a reminder to ourselves. What is the slope formula? It's this one. M equals, we have a fraction. On top, it's y2 minus y1. On the bottom, it's x2 minus x1. Okay, and over here we have our points, and doesn't matter which one you call point number 1 or point number 2. I'll call this point 1. So this is going to be my x1. This is my y1. And then I'll call this point number 2. So this is x2, y2. Let me go ahead and plug these in to the slope formula. Let me do this. Let me set this up. On the top, y2 minus y1. On the bottom, x2 minus x1. All right, so let's plug this in. The first thing here is a y2. So my y2 value is an 8. And you know what? Let me keep the colors the same. Here we go. y2 is an 8. Let me also plug in my x2 right here, which is a 5. And then I'm going to plug in my y1 right here, which is a 4. And I'm going to plug in my x1 down here, which is a -1. And notice here, look, subtracting a negative, and I'll put it in parentheses, okay? Next step here is to simplify this. Let's evaluate just the numerator. So on top, we have 8 minus 4. That's a 4. On the bottom, 5 minus -1. Subtracting a negative is the same as adding a positive. So this is the same thing as 5 plus 1, which gives us a 6. There's our answer. This is our slope, 4 over 6. But anytime we have a fraction, we want to check and see if it can be simplified. 4 over 6 can be simplified. I showed you how to do it on Desmos. Actually, you could also do it on your calculator now. I'll show you in class, if I haven't already, how you can simplify a fraction using the calculators that we checked out from the library. But you can also do it by hand. And to do that, you're going to check for a common factor in the top and bottom. Both 4 and 6 are divisible by 2. So I'll do that here. 4 divided by 2 is a 2. 6 divided by 2 is a 3. Okay, there's my slope. So I found the slope. Okay, part 2 here says, substitute the slope and 1 point into the point slope form. It says here, it doesn't matter which point you substitute. You're going to get the same, you get the same line either way. Okay, so let's do this. Let's use point number 1. So let me write this down here. This is the general form. Y minus y1 equals m x minus x1. Okay, the general form for point slope. Now we're going to plug in 3 numbers. We're going to plug in y1, plug in the slope, plug in the x1. Okay, so let's do this here. Y minus, and I'm going to use this point right here. So my first point, which I already labeled y1, is a 4. So I'm going to do this. Y minus 4 is equal to, m is the slope. That's what we calculated right here, 2 over 3. parentheses x minus x1, and our x1 value from up here is a -1. So again, here we're subtracting a negative, so I'll put that -1 in parentheses and then close parentheses. Okay, here's the equation of our line. Let's simplify this. What we can do here is, look, we're subtracting a negative, so that's going to change. Minus -1 is going to change into +1. So I'll just rewrite this here. Y minus 4 equals 2 over 3 x plus 1. There's our final answer. That's the equation of the line in point slope form. Okay, so you would be done here. What I want to show you, just so you can see this here, I want to show you this. You see how it says here, it doesn't matter which point you use? Okay, I'm going to do the same process with the other point, and then I'm going to show you that the two equations that we get are identical. Now, you don't have to do it both ways. I'm only doing this just as a demonstration. So let me do it over here on this side. Y minus y1 equals m x minus x1. Okay, we've got that, and now let's see, let me zoom out just a little bit. Okay, now I'm going to be using this point here. So let's do it. Y minus y1, so that's going to be the y value here, 8. So I'll use 8 equals, m is our slope, that's 2 over 3, x minus x1, that's going to be the x value from this same point, so that's going to be a 5. Okay, and that's a final answer for that one. We're not subtracting any negatives. There's nothing to simplify here. So, you see this? So we have two different equations here. Now, they don't look the same because this one has a -4, this one has a -8. This one has a +1, this one has a -5. But in fact, these two equations will give you the exact same line. I'm going to show you that right now on Desmos. So I'm going to go to desmos.com. Click the blue button here, graphing calculator. All right, what I'm going to do now, let me type in this first equation. Y minus 4 equals 2 over 3 parenthesis x plus 1. And hey, look, there it is. There's a line. We can see the graph, and this line does have a slope of 2 over 3. You could calculate the rise over run and get that. Now, my claim is that this second equation, which has different numbers, is actually identical. And the way I can show you that it's identical is if I plug it in down here on another line of Desmos. If it gives me the exact same graph, then those two things are exactly the same. So let's check it out. Y minus 8 equals 2 over 3 parentheses x minus 5. Okay, so the equation that I just typed in here is the blue graph. Let me go full screen Desmos. Okay. Now, where did the red graph go? We don't even see it. You know why? Because the blue graph is exactly on top of it. If I click the button over here to turn off the blue graph, look, there's the red graph. I can turn the blue graph back on. If I change one of these numbers, like let me change the 5 to a 4. Now you can see they're not the same line. The blue line and the red line are different. But if I go back to this, look at that. We just have one line. It's an identical line. Both of those equations give us the same line. So that's why it means over here in the notes, it doesn't matter which point you use. Okay, this piece right here. Doesn't matter which point you use. As long as you use the slope and one of the points, you're going to get an equation that is correct. Now it's your turn to give this a try. So down here on numbers 3 and 4, I want you to do the exact same thing that we just did here in the example. First step is find the slope. So to find the slope, you got to use the slope formula, and you have to use 2 points, right? So notice here for number 3, they give us 2 points. Label point 1, point 2, write down your x1, y1, x2, y2, calculate the slope. Second step, after you find the slope, plug into point slope form, which is this guy right here. Plug in your m for your slope and then pick one point. Doesn't matter which one you use, pick either one. Plug in for x1 and y1. Do that for numbers 3 and 4. Go ahead, pause the video, and then after you've done those, you can come back and check your work. Okay, these are the equations that I got for number 3 and 4. Check your work with mine. If there's anything that you're not sure about, anything you don't understand, make sure you ask me a question when you see me in class. Okay, ask me about it. I'd love to go over it with you. If you happen to write one of these equations and you use the point other than what I did, like for example on number 3, I used this point down here, right? I plugged in the blue point, but maybe you chose this point. So you have different numbers here and here. That's okay. If you want to check and see if your answer is the same with mine, you can use Desmos. Just like I showed you previously, plug in my equation, then plug in your equation on the next line. If the two graphs match up exactly one on top of the other, then you know that the answers are the same. If they're different at all, then you know there's something that's not the same. So that's a way you can check. All right, let's keep it moving here. Next page. What we're going to be doing here is starting with point slope form. We're going to change the form to slope intercept. A lot of times we're going to want to do this, change from one form of an equation to another. So let's go ahead and do this example here. It says write the equation of the line with slope 2 that goes through the point 4, -3. Okay, so this is what we've got here, slope of 2. So m value is a 2. This is, we only have one point here, so this is the one point that we have to use, x1, y1. We don't get a choice, we have to use that point. Let's use point slope form. So this is going to be it here. Y minus y1 equals m, parentheses, x minus x1. And let's plug these in. Okay, there's point slope form. We can clean this up just because notice right here we have minus and negative. We'll write that as plus 3. So let's do this here. This is going to turn into y plus 3 equals 2, x minus 4. Okay, so there's our point slope form. Now we're going to start with that, and you see what it says here? Rewrite in slope intercept form. Okay, just a reminder of what slope intercept form looks like. It's this, y equals mx plus b. So we want to convert this equation to something that looks like this. So how do we do that? Well, notice here, the y is all by itself on the left side of the equal sign. So that's one thing that we want to get. Also notice that here we've got parentheses, over here we don't. So we're going to do a couple algebra moves that's going to change this form into slope intercept. This is the first thing we're going to want to do here. Okay, when you have a number right here outside of parentheses, we can use the distributive property and distribute this in. Okay, now the reason we can do this is because we don't have an exponent. This is something that I just want to point out because this is going to come up later in this class. When we start Unit 2, not too long from now, we're going to be working with exponents, and it's possible we have an exponent right here. Like say we had an exponent here. If you have an exponent on top of the parentheses, then you can't distribute in. But since we don't have an exponent, we don't have one. So there's nothing stopping us. That means this is a legal move. It's all good. We can distribute in the 2. A reminder, when we distribute, the operation that we're doing is multiplication. So When you multiply a number times a variable, 2 times x, all we get is 2x. Here we're multiplying 2 times negative 4. That gives us a negative 8. Let's bring down the rest of the equation. Okay, and then the second step, which is going to be our last step, we want to get y by itself, but right now we have y plus 3. Well, we can achieve this by simply subtracting the 3. Okay, whatever I do to one side of the equation, I have to do it to the other side, right? This right here is the equation, is the equals sign. So this is what splits the equation into left side and right side. I'm doing it on the left side because it's going to cancel. I have to do it on the right side. And another thing that we have to keep in mind, we're going to combine like terms. This 3 is just a number, so it's not going to combine with the term that has an x. It's going to combine with the 8. I'm going to write it underneath the 8. And now we can do this. So 3 minus 3 is a 0. So technically this is y plus 0, but y plus 0 is just a y, because if you add a 0 to anything, it never changes. So what we say in short is that this cancels out. Effectively, it's gone. And all we have on the left side of the equation is a y, which is what we want. Y equals, the 2x term is just going to come down. It doesn't have any like terms to combine with. But right here, these are like terms. Those are going to combine. Negative 8 minus 3 is a negative 11, so I write that as minus 11. And guess what? We're done. Now we have the equation in slope-intercept form. And look at this here. Our slope is 2. I'll write it over here, right? I'll squeeze it in small down here. M equals 2. That's our slope. B equals negative 11. That's our y-intercept. That's y equals mx plus b form. Okay, the last thing I want to show you here before you try these, I want to show you, looking at Desmos, that these two equations are equal. Okay, so this is basically what we're going to do. We're going to go to Desmos. I'm going to plug in this one, which was our final answer for point slope form. And then we're also going to plug in this one, which is our final answer for slope intercept form. If we get the same graph, we know that those two equations are equivalent. All right, let's go ahead and take a look at Desmos. Okay, here we are looking at Desmos. I'm going to type in our two equations. Let me start first with point slope form. So that's going to be y plus 3 equals 2 parentheses x minus 4. And let's see, where is that graph? There it is. You see it? There's the graph. Okay. Next line, I'm going to type in our slope intercept form, y equals 2x minus 11. Hey, what do you know? How many graphs do you see here? Let's go full screen on Desmos. How many graphs do you see? I only see one. I see a purple graph. Over here, we've got two equations. We got purple and green. If I turn off the purple, look, there's the green graph. Turn on the purple. There it is. It covers up the green graph. That's showing you that these two graphs are identical, right? If I changed one little number here, like maybe let me change the slope here. Change this 2 to a 3 and take a look. Now they're not the same graph. But if I go back to what we had, exact same graph. So that's just proof that these two equations over here, they are indeed the exact same equation, just two different forms. One is point slope form and the other is slope intercept form. All right, so now it's your turn. Go ahead and pause the video and then try numbers 5 and 6. You're going to do exactly what we just did here. Starting with a point and a slope, you're going to write point slope form. Then you're going to convert it into slope intercept form. Pause the video, give it a try, then you can come back and take a look. Alrighty, these are the answers I got for point slope form. Take a look, compare that with your work. Again, if you have any questions, please ask me. I'd love to go over it with you. All right, we're going to keep going here. On the next page, we're doing something similar, except this is what we got here. We're starting with 2 points, and it wants us to write slope-intercept form. So this is what we're going to have to do. Start with the 2 points, use the slope formula to calculate the slope. Then we're going to use the slope combined with either one of the points, doesn't matter which one, you get to pick, and we're going to write point-slope form of the equation. And then the last step is going to be change the equation from point-slope form to slope-intercept form. So let's go ahead and do it here. Again, it doesn't matter which point you call number 1 or number 2. I'm just going to call this our first point. Call this one here our second point. Let's use our slope formula. y2 minus y1 over x2 minus x1. Go ahead and plug these in here. Eight minus 4 is a 4. 5 minus 3 is a 2. Here I have 4 over 2. We can definitely simplify that. 4 divided by 2 is equal to 2. That's our slope. M equals 2. Okay, now it says substitute the slope and 1 point into point slope form. So this is the general form. Y minus y1, m, x minus x1, y minus, here it doesn't matter which point you use. I could use the x and y from the red point or from the blue point. I'll go ahead with this first point. So my y1 value is a 4. Slope is what we just calculated. That's a 2. So I'll put a 2 here. X minus x1. And my x1 is 3. Okay, there we have the equation of the line in point slope form. Last step is to rewrite it in slope intercept form. So let me just rewrite it here. And now this is what we're going to do. Distribute in the 2. 2 times x is 2x. Distribute the 2 to the next term. 2 times negative 3 is a negative 6. Bring down the rest of the equation. Last step here. Plus 4, both sides of the equation. I'm lining up the 4 underneath the 6 because these are like terms. Those are the ones that are going to combine. Negative 4 plus 4 is a 0, which basically means those just cancel out. Y equals 2x. Negative 6 plus 4 is a negative 2. So this is going to be 2x minus 2. That's our answer. Slope-intercept form. Okay. Hey, look, now you've got a couple to try here. So go ahead and pause the video. Give numbers 7 and 8 a try. You're going to follow these exact same steps that we just did right here. So pause the video, try the examples, then you can come back and check your work. Alrighty, these are the answers that I got. Take a look at your work and compare. And as always, let me know if you have any questions. All right, now this last page here, we already talked about Hooy-Vooks. I just put this on here to give you guys a little bit of extra practice. So let's fill this in. As a reminder, Hooy-Vooks is our special case lines. It's our horizontal line and our vertical line. So H is horizontal, V is vertical, a horizontal line has a zero slope, m equals 0. And a horizontal line has an equation of the form y equals some number. Here's an example, y equals 10. That's a horizontal line going left to right through the y-axis at 10. All right, a vertical line is going straight up and down, and it has an undefined slope. M, undefined. And the equation is always going to look like x equals some number. Here's an example, x equals -6. So this is the equation of a vertical line going straight up and down, and it crosses through the x-axis at -6. Okay, so let's try some examples here. You know what? Let me let you try these first. Okay, I want you guys to stop the video and see if you could figure out what these equations would look like. Hey, look, here's a hint. If the slope is 0, it's this guy here, which means this is what your equation is going to look like. Y equals some number. Okay, if the slope is undefined, that means you got a vertical line, and the equation is going to look like this. X equals some number. So I want you to pause the video, see if you can figure these out, then you can come back and compare with what I've got. Okay, let's take a look at these examples. We'll start with example A. It tells us here the slope is 0. A slope of 0 means you have a horizontal line. A horizontal line always has an equation that's just y equals some number. So what number could it possibly be here? Well, let's take a look at the point of this line. This is the x value, this is the y value. Okay, there it is. That's going to be our y value, and the equation of the line is simply going to be y equals 4. That's all you got to do. Okay, part B, here it says slope is undefined. If the slope is undefined, that means we have a vertical line going straight up and down. The equation is going to be x equals some number. Well, what number could it be? Take a look over here. X value, y value. It's going to be this x value. Okay, yx, because that's what it tells us here. Vertical line, undefined slope, it's always the x value. So x equals -3. There's our line, equation of our line. Okay, let's come down here, figure out an equation for these. Okay, for part C, it passes through these 2 points. Now, let's go ahead and label this. This will be x1, y1. This will be x2, y2. Which coordinate is not changing? You guys see it? X value is 6 here and also here. So the x value is not changing. X value is staying 6. That means the equation of this line is x equals 6. And that's basically a vertical line going straight up and down through the x-axis at 6. And then the last one here, same thing. Let's do the same kind of analysis. Which coordinate is not changing? It's the y coordinate. Look, y coordinate is a -5 for that point, and also for this point. That means the y value doesn't change. It stays constant at a -5. This is a horizontal line going left to right, and it crosses through the y-axis at -5. And there we are. We're done with those examples. These were our special case lines, which are either horizontal or vertical. They have some pretty basic equations like the ones you see here. And hey, that finishes it up for us. So hey, thank you for sticking with me here, watching these notes and paying attention. I really appreciate it. Also, let me know when you see me in class any questions that you got pertaining to anything that we discussed here. And I'll see you on the next one. Take care.